Now we're going to take a look at the histogram. So when dealing with dot plots and stem and leaf plots, they're not always the most effective way for us to summarize numerical data, particularly when we have a very large data set. So histograms aren't always great for small data sets, but they are excellent for large data sets. Because we would use a histogram for large data sets, we are only going to use StatCrunch in order to create these histograms, but I do want you to understand what they are, what you're looking at, and when you would use them. Because we're dealing with numerical data and you'll have values on an interval, histograms are not going to be precise values like you had in a bar plot or a bar chart, because that was for categorical data. On a histogram, your values are going to fit into little groups. They're going to fit into little bins with all of the values between two numbers. So that's the major difference between a histogram and some of the other plots, is the histogram is particularly useful for continuous data. You can have a histogram with discrete data, and your textbook does go through an example of both discrete and continuous data. And we will look at one of these examples right now. This is looking at the promiscuous queen bees. There was a study done on the behavior of 30 queen honeybees because they wanted to learn about the length of the mating flights and the number of partners a queen takes during the mating flight. Particularly with the challenges, the environmental challenges with honeybees, we certainly want to know how they reproduce. So they calculated data on one mating flight and calculated the number of partners that the queen bees would have. And so here we have discrete data, so we have specific counts, and we are going to create a frequency table here. So we could count from 1 to 12, and we could get each frequency, and we could calculate the relative frequencies by taking the frequency divided by the total observations. But the thing about histograms is you often want to combine a few of these numbers together. So maybe we would want to put 1, 2, and 3 together. And then we would want to put 4, 5, and 6 together. And then 7, 8, 9, and then 10, 11, 12. It's going to form these intervals. And that's what is unique to a histogram, is that it's completely okay to put this interval together. So here we've combined our results into these 4 groups, 1 to 3, 4 to 6, 7 to 9, and 10 to 12, with the total frequency for those groups and then the relative frequency. The advantage here is now we're only going to have 4 bars instead of 12. Now typically we would strive for having about 5 to 10 bars, but it kind of depends on how big your data set is. So if we were to do a dot plot, it would look something like this, where we had each dot for each number here from 1 to 12. What I want you to imagine is drawing a bar instead of the dot. So we're creating these little bars above our numbers. So this is not really a great histogram with the 12 groups because it's all spread out. But when we are dealing with histograms, you do notice that we have these bars that are touching, and the heights correspond to the same heights that you would have seen in a dot plot. Now, in a histogram, you will not put the dots there, but this was just a visual to help you see the connections. Now, if we were to put these together and have them from 1 to 3, 4 to 6, 7 to 9, and 10 to 12, well, what that's going to look like is in this histogram. And so this is just a different grouping where we have these intervals, and we can see the center here. And you might argue that you liked the other histogram, and I completely understand why. 30 is a little bit small of a data set to be using a histogram, but we typically do want to have fewer than 12 observations when we want to have fewer than 12 bins or intervals when we're doing these histograms, particularly if your data set's less than 100.